Okay guys, hopefully this should just be a couple of catch-up videos after the live lesson, just to check through that your notes are okay to use for revision later, that kind of thing. So there's this video, the short one on the combustion aspects of the alkane-alkene reactions, and then there'll be a second video on the addition and substitution reactions, the reactions with bromine mortar, and why that one's very important. Okay, so to recap our live lesson, the combustion aspect. So combustion is defined as the burning of alkanes in oxygen, only oxygen, and there are two different types, as you can see here. So our first one is complete combustion. Now this only happens when we have excess oxygen. So what do we mean by excess oxygen? Well, if we write out the symbol equation, it is clear from the balancing here that you need 2 lots of oxygen molecules for every 1 methane molecule. So if we were in excess oxygen, you would have more oxygen than this ratio. So you would have more than 2 oxygens for each methane molecule that you have. So if you have this excess oxygen, complete combustion can happen. And in complete combustion of alkanes and alkenes, we only make water and carbon dioxide. Okay, they are our 2 products. The oxygen splits up, water, carbon dioxide. The word equation, again, water, carbon dioxide. So what does this look like? Well, we have our 1 methane to our 2 oxygens here. Oxygens are the red ones, methane, carbon, the hydrogens. So this is the correct ratio from our balanced equation. So we should be able to make waters and carbon dioxide from this. So obviously methane would break up like this, and then one of our oxygens would break up and join with each of our hydrogens to make our waters. So these will be our waters. Okay, and then of course we have enough oxygens still left to make our carbon dioxide. So this oxygen will break up and we will end up with our carbon dioxide made, because there is enough oxygen to react to make the carbon dioxide. Note the double bonds, the 4 shared electrons in the carbon dioxide. So water, carbon dioxide. So our second type of combustion is the incomplete combustion, and this happens when oxygen is limited. So what we mean by oxygen being limited is there are less oxygen molecules than the ratio of the balanced equation dictates. So if you remember our methane, we had 1 methane to 2 oxygens, would give us complete combustion. But in this case, we have 2 methanes to 3 oxygens. So there's not enough oxygens to completely react with both of the methanes. We've got a 1 to a 1.5 ratio rather than a 1 to 2 ratio that we need. So we make different products. You will always make water. Okay, so the water will always be made. The oxygens will always collect up any of the hydrogens that are present first. The carbon will then form carbon monoxide with 1 oxygen if there's enough oxygen present left over after the waters are made, and if there's not, the carbon will just remain by itself. And you see this quite often in flames. It's smoke, it's the black smokiness coming off the top of a flame when there's not enough oxygen being supplied to it. So as you can see at the bottom, to balance our equation for incomplete combustion, we have to have 2 carbon monoxides. Last note, combustion works exactly the same in alkenes. So if you have enough oxygens, if you have excess oxygen, you will have complete combustion. If you don't have enough oxygens, you will have incomplete combustion. Something to note, usually with an alkene, you will need more oxygen per alkene molecule. So this tends to lead to more incomplete combustion happening with alkenes, and usually a smokier flame, but that's only a general trend. So let's have a quick look at the models with incomplete combustion. So as you can see, this time we have our 2 methane molecules and our 3 oxygens, so we are limited in our amount of oxygen. And the same as I said before, the hydrogens will all go onto the oxygens first, so you would take off those hydrogens and attach to oxygens. So I'll do that quickly so you don't have to watch it. So we have made our 4 water molecules, we've got our carbons left, we still have 1 oxygen left over. Now it's far more stable to have 2 carbon monoxides rather than 1 carbon dioxide and 1 carbon. So this oxygen will split in half and form the carbon monoxide, like so. So we would have 1 carbon monoxide and 2 carbon monoxides. Now in reality, guys, these have 3 bonds. There should be a 3rd bond joining over to the oxygen here like this, but my oxygens on my Molly-Mod don't have 3 holes in, so I can't attach them, but it should be a triple bond like this. So this forms because we do not have enough oxygens to make the carbon dioxide. So you have an example of an alkane burning. You may have some of these around your house, you may not, depends if you've got candles or not. So lighters are butane, our 4 carbon alkane, and for combustion obviously we just get flame. The yellowness of the flame is because it's not all complete combustion. If we had complete combustion, we'd have that lovely blue flame that we get with the Bunsen burners at school. Obviously quite hard to do at home because no Bunsen burner. But if I could restrict the oxygen to this even more, the flame would get more and more orange and you'd see more and more smoke.